Hi, Amy. How are you doing?
Hi, sir. I'm good, thank you. How are you?
Very good. So we have been doing trigonometry. How do you find it so far?
Really good. So, like the chapter that we've completed, in my book anyway, it's called the radians section, which had all the arc stuff, and then even just up until our last session, which was small angle approximations, and
Mhm.
then the percentage error questions. All of it I can do like fairly nicely with ease, which is
Very good.
nice. And I guess you did talk about last lesson. We were moving on to the next chapter, and it looks like in my book it's like cos A and sin A questions. I think it's some sort of
A
formula. I'm not
plus
really
BN.
too sure.
Yeah, yeah.
That's it. Yeah,
Then next unit for you is the compound angle formula unit.
yeah.
So I'll expose you to that compound angle thing. In fact, I'll
Okay.
derive most of the formula. So it'll be very easy for you to solve those type of questions because once you understand how to work with compound angles, it is
Mm-hmm.
very simple. So let me just share with you a lesson prepared. I have to do most of the derivations, so I'll actually put the screen flat. You might not see me while I'm doing the derivation,
All right.
but I think you'll see the contents. That's more important. So let me just share. So do you see my screen?
Yes, I do.
Perfect. So these are all the formulae which are required for your next unit. We call them compound angle formulae, correct?
All right.
So to begin with, let's say uh, on the left hand corner, we have compound angle formula sine A plus B. You see, we have an angle A plus B inside. Sine
Yeah.
A plus B is sine A cos B plus cos A sine B. Sine A minus B is sine A cos B minus cos A sine B. Cos A plus B is cos A cos B minus sine A sine B. And cos A minus B is cos A cos B plus sine A sine B. So these are the kind of formula we call, these are your basic four formulae. Now, from these basic formulae, we can derive many others. One of them, which is very important, is the double angle formula. So we'll see how do we derive double angle formula from the compound angle, and then product to sum formula and sum to product. So there are many questions which will involve what is sine alpha cos beta equals to. And we can actually relate them to the compound angle formula. All these formulas are given here on this particular sheet for your reference, right?
Okay.
Before we get into all this, let us try to understand why do we need this compound angle formula. I hope you remember that our special triangles. Let us say if we have a 45 degrees triangle, let me just make a right angle triangle with 45 degrees. Then the sides are known to you, the ratios. I mean, so if it is 45 degrees, in that case, if these two sides are equal, let's say 1, then the hypotenuse is the square root of 2, correct?
Right.
So that is what it is. On the other hand, if I have a 30, 60, 90 triangle, which is, I could draw it here itself, right? So let me just draw it like this. Let us extend this. In that case, that angle becomes 30 degrees. And this is 60 degrees. So in that case, the sides are 1, 2, and square root of 3. Sorry, I should have drawn a new diagram. Anyway, sorry, we 1, 2, and square root of 3. Let's do it. So that is your 30, 60 triangle, which has been like, normally we draw an equilateral triangle and then do it. But if you want to keep that one as a constant, same side, let me
Yeah.
redraw 30, 60, 90, which you normally see, so that you can tilt it and then figure it out, right? So if it is 60 degrees, then we have 1, 2 square root 3, correct?
Mm-hmm.
That is what you're familiar with. So let me just say, is that clear to you? So we know our special angles. That is, if I want to know what is cos of 60, I can easily read from these special angle triangles, it is equal to half. And what is sine of 45? 1 over square root 2, right?
Yeah.
Very easy. But now, if my question is what is cos of 75 degrees, for example, right? Now, how do you figure this out? Well, you know that 75 is sum of 30 and 45, correct? You could always write this as cos
Mm.
of 30 degrees plus 45 degrees. I wrote 45 first anyway. So, and then you can figure it out. Now, see, We know what is cos of 45, what is sine of 45. We also know what is cos and sine of 30 degrees. We could use one of these formulae, right? Cos
So
A
the
plus
cos A
B,
plus B. Yeah.
and then find the exact value for cos of 75 degrees. You get the idea.
Oh, right. Okay. Yeah, yeah.
Do the combinations of all these angles. For example, we could also do what is 45 minus 30. So we get cos of 15, right? Or sine of 15 for that matter, right? If I want to find 15 degrees, I could say this is sine of 45 minus 30 degrees, correct? And I can use sine A minus B formula to find this exact value. You get the idea?
Yeah, I do. But if we have the calculator, do they just want us to show the working out using these formulas?
Okay. Without calculator, if you have a test, then what will you do?
You need to know
Then
these
you
formulas.
have to know this formula, correct?
Yeah,
So
fair enough. Okay.
this is very important because one of the test paper could be without calculator many times, right? Especially for our IB students, they have one calculator, one without calculator test, right?
Oh, okay.
Now, we will derive half angle or double angle formulas. Right? If I write sine 2x equals to 2 sine x cos x, then I could also say, let me get to this formula. I could say, what is sine theta equals to? So that is to say, I'm writing 2x as equal to theta, right? So in that case, sine theta will be 2 of sine theta by 2 cos theta by 2. Do you see that? So I have also converted the same a plus b formulas to 2a, to half a. There are so many combinations we could do. We could extend these formulas to derive for sine 3a, sine 4a, sine 5a.
Yeah, yeah.
There is no end to it. That means now you can find exact value of any angle, correct?
Right.
Any angle.
'Cause you can, yeah, yeah.
This double angle formula will give you half of 45, which is 22.5 degrees.
Yeah, so you can get anything. All right.
So now you can actually calculate exact value of any angle using these formulae, right? So that's a base for you. And many questions will involve sine and cosine as a product. In that case, we will use the formula which is converting product to some formula, right? Because these are our basic formula, correct? Similarly, if you are given sum of sine and cosine functions, right, any combination, we could actually write them as product of these formulas. So you can see huge importance of these formulas and their application in real life situations. Correct?
Right. Yeah.
For example, if I am tracking an airplane, right? So if position A gives me an angle alpha, position B gives me another angle beta, in between, if I want to check what distance it covered and whatever, right? If I have to solve that particular triangle, it will be beta minus alpha. You get the idea?
Oh, yeah, yeah, yeah.
Many practical examples are now related with the sine angle formulas, compound angle formulas. So it's a huge importance, right?
Yeah.
Simple pendulum oscillation, all those. Now, any wave, which is periodic kind of sine wave, we could solve using these formulas. And let me tell you one thing: any wave can be, any periodic wave can be written as a combination of sine wave. So now you can understand any periodic wave, any.
Oh,
Can
wow.
be written as a combination of sine wave, yes.
Mm.
So that gives you huge advantage of these formulas. You see that?
Yeah, yeah.
Some calculations you may think are very difficult for you to do, but imagine if computer is working on the same calculations, they can immediately figure it out.
Yeah, yeah.
The only thing difficult for computers is to figure out the equation itself.
Yeah.
We will provide the equation and the method today. You get the idea.
Oh, I see. Yeah, yeah. They just give the answer.
Equation?
Yeah, the equation is the main part, because then how do you input things? Yeah.
So that is what we are going to do today. So I hope it will be very interesting. And the proof, you'll love it. It is so easy that I've just written sine 2x, cos 2x. You will write sine 3x, sine 6x, whatever.
Yeah. Oh, right.
And do questions like nobody's business.
Yeah. That sounds appealing.
Correct. So let me move forward and see how do we derive these formulas. So on this page, what I've done here is, specifically for you, I've kept these formulas on the left-hand side, right? So that you keep looking at them. The idea is if you keep looking at your formula, you kind of remember them, right? You don't have to make an effort to remember. You get the idea.
Okay. Yeah. Yeah.
I never make an effort to remember any formula. I just do 10 questions based on it. So when we do
Oh.
10 questions, the formula itself gets somewhere stored, which can be easily recalled. That's kind of important, right?
Oh yeah. Yeah.
Storing is not enough. So we have to recall it when required. So that happens only when you practice, correct?
Right. Okay.
Another suggestion is that once we are done with this, I like you to go through my playlist, just type in or search for Anil Kumar compound angle applications or
Yeah.
compound angle playlist. You will get hundreds and thousands of videos which will explain you with many different examples, all these things which we are talking about. Okay.
Yeah. Yeah.
So foremost thing is just to understand the formula today and see how they are connected.
Okay.
I shouldn't
Yeah.
say derive. I'm just saying, how do we connect them, right? That is what we'll try to do. So let me just make this screen flat on the table and then we'll continue with our lesson. So our starting point is the compound angle formula, which could also be derived, but in this lesson, I'm not deriving what is sine A plus B, right? So
Yeah.
I'm actually starting with what is sine A plus B. So I'm saying sine A plus B is given to us, which is equal to sine A. Do you remember? Sine A cos A, try to
Cos
remember.
B
Yeah.
plus cos A
Plus
sine
cos A
B.
sine. Easy, right? Do you see that?
Like, yeah, reversed.
If I do sine A minus B, the only thing is think about B change to minus B, right? And you know, sine is an odd function. Do you see that?
Yeah.
So if I do A minus B, the only sign which is going to change is that B becomes minus B. So important thing to remember here is something like this. What is sine of minus theta equals to? It is minus sine.
Minus sine theta.
And what is cos of minus theta equals to?
Cos theta.
Because cos theta is an even function. You get the idea.
Right.
So I don't even have to write what is minus because minus means replace b by minus b, right? Cos will
Yeah.
never change. It will remain the same, correct? So in that case, we'll get what? We'll get sine A cos B. That becomes minus because sine B and minus sine B. It's an odd function, right?
Yeah.
Cos A sine. Is that clear to you? Now
Yeah.
we are interested in deriving the formula for the double angle, for example, right? So what is double angle formula? So double angle means if I replace B with A, if I write B equals to A, right? So what happens? So let us look into the first equation. Let's only look at the first equation, right? So I'm erasing this minus B. You understand it's an odd function. If I
Yeah.
replace B with A, I could write this as what? I could write this as sine. I'm writing B as A, so it is A plus A, right?
Yeah.
Equals to sine A cos A plus
Plus cos A
sine A, right?
sine A.
That is 2 times sine A cos A, right? Both are same terms.
Oh yeah.
And the other side gives you sine of 2A. So that's the double angle formula for sine. Is that clear to you?
Oh. Mm-hmm.
Difficult. So simple. Do you see that?
Yeah. Very simple.
B with A and got my formula. Well, I could do the same for cosine also, right? Easy.
Yeah.
Now I'll write cos of A plus B equals to. The cos of A plus B is cos A cos B minus sine A sine B.
You're
If I-
replacing B with A.
Yeah, so I'll replacing B with A, right? So I get what? I get cos A minus sine A sine A. Is that clear to you?
Mm-hmm.
So
Yes.
that gives you what? It gives me cos square A minus sine square. So that becomes the formula for double angle when cosine is there, right? Do you see that? So we have derived the cos 2x formula. So simple as that. I mean, simple substitution. We're just changing
Yeah.
the way the other angle, make them same angle. So we get double angle, correct? It makes sense, right?
Right. Yes.
Okay. Now, this is a very interesting and powerful formula. When we are writing cos 2x, let me highlight this formula, right? Very, very important. I'll tell you why it is so important. What is cos square A? Cos square A can also be written as 1 minus sine square A.
Sine square A. Yeah.
And sine square A can be written as 1 minus cos square A. Correct. So in this particular formula, if I replace, let us say sine square A by 1 minus cos square A, what do I
Mhm.
get? See, cos square A minus 1 minus cos square A. In
Two
that case,
cos-
what happens? This minus becomes plus, and I get 2 cos square A minus 1.
Yeah.
So that gives me the third formula. And now, if I do the substitution for, let us say, cos, right? So if I write cos square A as 1 minus sine square A, let us say, right? In the very first equation, which is this one, which already has sine square A with a negative sign, that will give me 1 minus 2 sine square A. Do you see that? So we have
Mhm.
another formula for cos 2x, which is 1 minus 2 sine square x. Is this all clear to you?
Yes, it is.
Now, the beauty of these two formula is from cos double angle, you are writing in terms of sine. You have converted the equation in terms of sine. Now, if you look at some examples which will involve quadratic equations, for example, let us say
Yeah.
in quadratic equations you have both sine and cosine terms, okay? To solve the quadratic equation, you should have only one term,
Oh,
either in cosine or in sine.
right.
So
Right.
this angle formula for cos helps you convert the whole equation in one term, either sine or cosine. You get the idea.
Yes.
Then you can solve any quadratic equation. So that's the beauty of it. So with that, we have seen the link between the compound angle formula and all the double angle formula.
Yeah. Yeah.
As an exercise, what you could do is derive a formula for cos of 3a, right? How? Well, simple as that. Cos of 3a is what? It is cos of 2a plus a, right? That is 3. Already you know
Yeah.
what is cos of 2a, right? You know what is cos of 2a.
And we know what A
Cos
is.
a plus b, right, formula? Now you can just expand and keep on deriving your formula for 3a. Similarly, you could also derive a formula for sine 3a. No harm, right?
Yeah. Yeah.
Very simple. These are actually very important formulas, which will be used so many times. So deriving them will be a good exercise to do. Correct?
Okay, I will do that.
Yeah, sure. Now, what is next? Next type of formula which you're looking into is product to sum. Okay. So before coming to product to sum, there is a very interesting formula which I would like to share, but I could do it here also. I'll do it here. So let's again begin with sine a plus b formula. So sine a plus b, now you remember, is sine a cos b
Cos B
plus cos
plus sine A.
sine b, right? Good. Now, what is sine a minus b formula?
Sine A
Yeah,
cos B minus cos A sine B.
very good. Now, what happens if I add them?
Wait, both of those.
Yep.
Does it cancel? Wait, what cancels? The cos A sine B cancels with the cos. Yeah.
So
And
we
then
get
you
a
get
formula for sine a plus b plus sine a minus b. You get the idea.
equals 2 sine A cos B.
2 sine a cos. Correct?
Mhm.
Now, think like this. If I make b as equals to a,
You get
okay,
sine 2A.
okay. You see what we're trying to say.
Yeah,
When you
yeah.
have a formula, then in that case, the connection is something like this. You could change B with A. You can change both with alpha, for
Oh,
example. You can
yeah.
make it, right? So anyway, so let us see. What we have done here is we have written this is a product. You see, this is a product.
Yeah.
And on this side, what do we have? Sum.
Sum. Yeah.
You see, we have a sum on one side and the product on the other side. And therefore, we call this, if I rewrite this, if I write what is sine A plus B equals, sine A is cos B is equals. So sine A cos B, taking half, one to the other side becomes half, right?
Oh, yeah. Then sine
Right.
A plus B
Yeah, A plus B.
plus sine A minus B.
You get the idea.
Yeah.
So I have actually in an equation, if you have the terms together, sine A cos B, I could write them as this. You get the idea.
Mm,
So
that's
rearrange.
good. Yeah, it's just all about rearranging. Because
It's
it
all-
looks complicated on the side, but then when you did it like that, it was really straightforward.
Yeah, yeah. So imagine if instead of plus I do minus, then what happens? Let's do it, right? Instead
The
of
sign
plus,
goes.
yeah, the first term goes, and we get the
Yeah.
other term, right? So we'll get cos A sine B, right? So I could write
Yeah.
this as, let me use another ink here. Okay. So if I do minus, if I have sine A plus B, so you can play around with this. You get the idea.
Yeah. Yeah.
It's fun. If you minus, then the first terms cancel, and we get 2 cos A sine B, right?
Mhm.
And that gives me the other formula, which is this one. So which is cos A sine B is equals to half of sine A plus B minus sine A minus.
Mhm.
Clear?
Yes.
Very simple. Same thing you could do with cosine, right? So we know what is cos A plus B equals to, right? We know what is cos of A minus B, right? So once you add them, you'll get one set of formula. If you subtract them, you'll get the other set of formula, and you'll derive these two. You get the idea.
Oh, okay. Yeah. Yeah.
Very simple. Then you rearrange. So the product is on your right hand side, and say what? Right hand side is equal to half of the left hand side. And that's the formula, right? Do you see that half of the left hand side, right?
So you never really need to like actually like sit down and memorize those because you can always just get it back again as long as you know because you can just rearrange.
Yeah, you just rearrange, right?
Yeah.
So easily we could write this formula in this fashion, right?
Mm.
Okay. So we
This is the
learned
most easy. Sorry, but this is the easiest like you've ever like derived formulas.
yeah,
It's
it
like
is.
so quick. Yeah.
It is. It is. And now this was product to sum. Many times you're talking about sum to product, right? So you didn't have to do the other way. Sum to product. Let's see this. So sum to product is a scary formula. We have sine alpha. Let me just increase this to show you what exactly the formula is. Sine alpha plus sine beta is 2 times sine alpha plus beta divided by 2 cos alpha minus beta divided by 2. Very scary, right?
Mm.
How are
To
we
look
going,
at.
how are we going to do it? Oh my God. So I will show you such a neat technique of doing it, right? We'll
Okay.
try to relate it with our previous formula, right? Previous
Right.
formula, let's go back and see what the previous formula was.
It was
Very good. So
sine
we have this sine alpha cos beta is half of sine alpha plus beta plus sine alpha minus beta. You can see that
Yeah.
previous
Mhm.
formula. And this formula, can you relate the two? That product, because sum to product to sum seems to be equal, right? Similar, right? So there has to be a connection.
But this one has half and that one has 2.
Yeah,
in
yeah.
front.
So that is the
So-
other side, right? So initially,
Yeah.
when we wrote, initially you remember what we wrote. We wrote sine A plus B plus sine
Sine A minus B.
equals to 2 times
Sine
cos B.
A cos B.
We wrote this right initially.
Yeah.
Then we took the 2 other side and did half of it, correct?
Right.
What does that suggest? How do we relate alpha plus beta by 2 with A plus B and all? Very clear. If
Mhm.
I write A as alpha plus beta by 2, then what happens?
Oh.
So
Then you've
what I'm
literally just subbed it in.
A as alpha plus beta by 2, right? And I'm writing B as alpha minus beta by 2. Is that clear?
Yes, it's literally the same formula. Oh my God.
So I can write down the right hand side as 2 times sine of alpha plus beta. I should write beta as properly, not like b, right? So alpha plus beta by 2, and then cos of alpha minus beta by 2, correct? What is happening to the left hand side? What is a plus b equal to? Let's
It
try it.
says alpha. Oh, and then A minus B is beta.
Yeah, a plus beta is
Oh,
alpha plus beta by 2 plus alpha minus beta by 2, which is basically alpha, right? 2 alpha by 2, right? You can say 2
yeah.
alpha by 2, which is alpha. Similarly, this difference is beta. So this left side is sine of alpha plus sine of beta. Do you get the idea?
Wow. You really made that not complicated. That's good. Oh, so I didn't realize it because the format's the same, but you just sub the different things as A and B. So yeah,
Right.
makes sense.
Right. So we use alpha, beta, x, theta, all these terms just to relate and connect these formulas. So these are very interesting formulae. And if you just know the basic, which is what is sine a plus b equals to, right? What is
Yeah,
cos a plus b equals to?
you
Then
can get all of these.
you can get all of them,
Mm,
because you have to just change b to minus b to get what sine a minus b is equal to, right?
yeah,
And you have to change sometimes a plus b divided by 2 to some other thing.
right, right.
Right?
It's
You
clear. Yeah.
change b to a to get double angle formula, right? Once you do
Yeah.
that, you can change b to 2a to get triple angle formula.
Wow. Yeah, you just need to know the basics and then you can do all of them. It's quite
All of
impressive.
them. So there could be thousands of questions based on this particular concept, which will seem difficult, but will be very, very simple for you to do, right? So I'll now show you some very interesting questions which could be done based on this. For example, when we talk about identities, do you see this identity? Cos
Yeah.
2x, sine 2x plus cos 2x plus 1 divided by sine 2x plus cos 2x minus 1 is equals to cotangent of x. Very difficult identity. But if you know what cos 2x is, if you know what sine 2x is, we just derive those formulas, right? We
Yeah.
can use those formulas, substitute the value, and prove this identity, for example. You get the idea?
Oh, so yeah, should we do that?
No, I'll not. I like you to do it later. So
Oh,
you
okay.
copy this question or take it from my. So we'll solve these types of questions later.
Right.
They
Yeah.
will require the strategies which you learned in solving identities earlier, right? So
I see.
let's get back to the screen and discuss how do we solve some very difficult questions based on these formulae. Okay.
It's good. So yeah, we can just sub them in and then because we've already derived the formula.
Okay, so let me begin with simpler questions rather than going straight into this. So here we have two questions for you. So the very first question is to solve the following equation. You can see the screen, right?
Yeah,
Can you
okay.
read the question, please?
Yeah, so solve the following equation for x between 0 and 360 degrees, both included. So part A, cos 2x plus cos x plus 1 equals 0.
Yes.
And part B, 4 tan x, tan 2x equals 1.
Today we did not learn about the tan double
Tan.
angle formula. We'll keep it for the next time. So we'll skip
Okay.
that question for today. So the first question, how will you solve this? Can you tell me? Cos 2x, right? It's kind
Yeah.
of a equation to be solved. So we
So
could use double
cos
angle formula.
2x
Yeah.
is cos squared A minus sine
Cos
squared A.
A. Yeah, you're right. So now the quadratic equation should be written in one cosine only or sine only. So we had
Okay.
three formulae. So we'll use this formula of cos square 2 cos square x minus 1. Do you see that? I know what you said was this cos square a minus cos square
Yeah.
x minus
And
1.
I know what you said. You just rearranged it. Yeah, because you made sine squared x as
Yeah,
1 minus
1 minus 2 sine square.
cos. Yeah.
We had three forms, right? So whenever it is cos term, in that case, we are seeing into out of these three, which one to apply.
Oh, right. Okay. Yeah.
In this particular case, we have cos 2x along with cos x. I can solve a quadratic equation provided I have the same parameter.
Right. So as cos in this case.
So I will substitute this value here. And now it becomes very simple. I could write this equation as what? Substituting 2 cos square x minus 1 plus 1 is 0, right? So we get 2
cos squared x
minus 1 plus cos x plus 1 equals to 0.
So
now look here, this minus 1 and plus 1 will cancel. So we could factor this, right? So we could write cos x 2 cos x plus 1 equals to 0, right? So that gives you a solution that either cos x is equal to 0 or cos x is equal to minus half.
Yeah.
Is that clear to you? Now, we are given the angle between 0 to 360, and we know when is cos x half and what is 0, right? We know that. Cosine function is kind of like this, right? I prefer to draw like a sine function anyway. So that is what cosine function is. And 0, it is at 2 points. These are the 2 points. And we get 90 degrees and 270 degrees for 0, correct?
Yeah.
And as far as the half is concerned, we are looking for negative answers. So that means we are looking into these two angles.
Quadrants. Yeah.
And obviously, half and square root 3 and 1 are related by 60, 30, 90 triangle. So that is half, correct? Cos. So we're looking for acute angle of 60, correct?
Yeah.
Therefore, the answer is 180 minus 60 and 180 plus 60. So we get two answers which are plus 60 and 180 minus 60, correct? And that, if you add that, we get 240 degrees. And
120.
Take it, you get 120 degrees. So those four becomes the solution of your equation within the interval of 0 to 360 degrees. You see that?
Right. Yeah.
How easy it is?
Very easy.
So once you understand the concept, then all the things which you had earlier done with the so far, all those things can be now applied with this added information. Is that clear to you?
Yeah, very clear.
Correct. That is how you have to do.
Yeah.
Now, when you will be working on this identity, which is slightly difficult to work on, sine 2x cos 2x plus 1, right? So now we have double angle formula for sine 2x and cos 2x.
Yeah.
As far as sine 2x is there, we have only one formula for sine 2x. So it is
2 sine A cos A.
Yes, 2 sine x cos x, correct? So if you put 2 sine x cos x here, and for cos 2x, since we have plus 1, look here, strategy is plus 1. If there is plus 1, I could get rid of this plus 1.
With the minus 1.
With a minus 1. So I will use this one. Is that clear to you?
Oh, okay, yeah. Because you could use either, or you want to get rid of the 1, so you use the minus 1. Got it.
Minus 1. I'm only doing numerator for you so that you know, you get an idea. So if I do that, I already get 2 sine x cos x in the first term. And now for cos of 2x, I substituted with 2 cos square x, right?
Minus 1.
Minus 1. So that minus 1 cancelled. So I'm just writing the numerator as this. Do you see that numerator? Now I can factor out cos x.
Yeah.
As soon as I factor out, in fact, 2 cos x I can factor out, right?
Oh, yeah. 2 cos x.
So I get sine x plus 1 and I can solve the equation.
Oh.
I'm just trying to say that if that would have been the equation.
Yeah, yeah,
this
yeah.
is an
Without
identity.
the denominator.
Well,
yeah, I get it.
This is an identity, but you could simplify an identity in a certain fashion. Correct?
Oh, that was very smoothly done.
So we could do many things with whatever is given to us. You know, it's how you look at it. How do you connect with it? That is kind of important, right? I could ask this question as an equation rather than an identity. Why not?
I see. It's being about strategic, about what equation you're subbing in, because like we saw for the cos x, there's multiple ones for that one, but it's about trying to simplify it and like get rid of terms. So you've got to use what you know to the best, to the appropriate like way in the question.
Denominator, cos 2x minus 1. So cos 2x minus 1. To get rid of this minus 1, I'll prefer to use 1 minus 2 sine square x. I'll get rid of that thing. Once I factor numerator and denominator, now you can see the solution of the identity, right? And common factors get cancelled away and we get cot x on the right hand side. Do you see that?
Yeah. What is because I don't think it's in my book, but cot x, I've done it with you before. Is it something with
1
tan?
over
1
10,
over
right?
tan?
1 over 10. Yeah, yeah.
Oh, okay. What's the other one? The secant one? I don't
Secant
know
and
that.
cosecant. Yeah, yeah, yeah.
I don't think
So there's a reciprocal identities.
Oh, right. Okay.
Okay, so you get an idea. So we can
Yeah, I
actually
need to.
solve these questions very easily, provided we understand how do we apply the formulas which we know.
Right. Yes.
Efficiency is a great thing. We have solved all these questions 3 steps. Did you realize that? 3 steps?
Oh,
Somebody could spend the whole day solving them or a
yeah.
page. No, no, we don't need that. 3 steps done, right?
Wow.
So
Yeah.
that is how you. So another question I'm sharing with you, which is a very interesting question. Here is the solution also. Uh, I think we did this. Oh, we did this one, right? We did this, right? So we have
Yes,
those
we
4
did.
answers which we had correct,
We
and
got
the
them.
identity also. That's it, right? So anyway, so we could move on to similar topics which involve, as you can see from here, the formula for cos 2x is written right before you, correct? Which is 2 cos square x minus 1, and which is also equals to 1 minus 2 sine square x, right? And also, you know, it is difference of squares for cos square x and sine square x, difference of squares. Now, the question could be, derive the formula for cos 3x. So right there, we have a formula for cos 3x. So your exercise is to derive the formula for cos 3x and also for cos 6x. How are you going to do it? I have given you the formula here. So it is easier for you to derive this particular thing. You get the idea?
Oh, so wait, so when you got 3x, did you just use the 2x1,
Yeah, yeah. 2x
but
plus
then
x.
sub in it's
Yes,
3?
yes, simple as that. So I'll just expand in this formula. I'm writing A as x and B as 2x.
Oh, okay. Yeah, yeah. But how do
And
you know which numbers to use? Does it matter? So if you were
no,
going
no,
to do
you want
6,
3x, right? You can
yeah.
write 2x plus x, doesn't matter. One is the same thing.
Oh, yeah, yeah. But I mean, like, let's say if it was 4x, do you have
Yeah.
to do 3x
No, no,
and
4x will
x?
be 2 times 2x.
2x, 2x. Okay.
4x will
So,
be double angle twice. So you have to think. So 3x to 6x purposely is given to you. Once you know 3x formula,
3x
this is
times
double
2.
angle formula, right? Do 2
Right.
times 3x. Then you get 6x formula.
Oh, I see. Yeah, yeah,
So this exercise is like, is a strategic exercise.
yeah.
How do you apply a strategy to get the solution fast?
Right.
So simple formula, which we know, cos A plus B is cos A, cos B minus sin is sin B. But with that, we can find so many formulas, right? Just as we have right here. You get the
I
idea.
see. Yeah, very clear.
So this is what you need to practice a bit. Once you do it, all these formulas which we learned
It
today.
sunk in my head.
Yeah. Now have a look at from where did we start today? Such a
We started with the formulas.
Right? There are so many of these pages in a book. They will like fill up 20 pages with these formulas, right? And
because you can keep going.
Yeah, and examples based on them. We finish it off in about half an hour, correct?
Yeah. When I looked at this in the beginning of the lesson, I was quite like scared because it's just a lot of stuff going on, and it looks like you said it does look scary. But then, as long as you know those 4 main ones, the compound angle formulas, you literally can find every other one. Like the double angle, the product to sum, the sum to products, like it's like really wow. So yeah.
So you begin with, I will say, a simple special triangle, which is 45 degrees, 90 degrees triangle, and then another triangle which is 30, 60, 90. You have the exact values of sine, cosine, tangent, right?
Yeah, yeah.
Now from there, we get to these compound angle formulas, and we start calculating values for sine of 15 degrees, sine of 75 degrees. That should be your first question to do. Apply the formula and calculate the exact value for sine 15, cos 15, sine 75, cos 75.
Oh, right. Okay. Yes.
Now, as you know, complementary angles. So you could use this concept, which is, you know, that in a right angle triangle, if I look at from the other side, what I'm trying to say is, what is cos of 90 minus theta? It is sine theta, right? So if this is theta, right, this is phi, which is 90 minus theta. Is that clear to you? It is sine theta. So what I'm trying to say is 90 minus 15 is equal to 75 degrees. Do you see that? So if you work for just sine, you get cosine value also.
I see. Yeah. The cos and sine are so interlinked in every way. Like
Yeah.
when we did it graphically, when we do it like this,
Correct.
they're just so like in sync
So,
with
so
each
what I'm
other.
trying to tell you is you just work on sine. Why do you work for even cosine, right?
Sine
Calculate
is the
all the
main
values
one.
of sine, and then you know cosine is 90 minus theta. So you get all
Right,
the
right.
values for cosine. I mean, just working smart, right?
Yes, yeah. Smarter, not harder.
You don't have to do both these questions, correct? One of them is enough to get the
Right.
answer for both.
Oh, I see. Yeah, yeah.
Because the other one is 90 minus 15. We are done. That's
So
enough.
let's say you did sine of 15. So let's say you did sine of 15 and you got a value,
Yeah.
whatever it is. Do you just do
It is
90
it
minus
is
that value?
yeah, then you say that is also cos of 75 because 90 minus 15 is 75, correct?
Oh, okay.
You
So you
don't
can do
have
it
to
like that
redo
as
it.
well.
You
Yeah,
don't
yeah.
have to redo it, apply the why? I mean, save your time.
Yeah, yeah,
You
yeah.
get the idea. So work smart. That's what I'm trying to say here.
Right.
So when you are working, I mean, for practice, you should take sometimes sine, sometimes cosine, just to be familiar with both the formula, right?
Yeah.
And then check your result and keep doing it. Like you start from one side, let's say 50, for sine, you do 50, you know 30, 60, but you don't know 75, you know
Yeah.
90, right? In between, you have so many sums and differences which you could do
Oh,
and get
okay.
your solution, right?
Got you. Yeah, yeah, yeah.
So that is
Makes
how we
sense.
can do it. Even we could do sine 90 minus 75, 90 minus,
Oh,
and
to
get
get
a
sine.
simpler result, right? Because
Yeah.
sine 90 is, as you know, is 1, correct?
Yeah.
Cos 90 is 0. It is easy to calculate. Even if
Mm,
you have to calculate, you get the idea.
it's very easy. Yeah.
Very
I
easy.
see.
Why should I take uh,
So much time.
some other value? Yeah. You get
Yeah.
the idea, right?
Yeah,
So that
yeah.
is how we have to work on all these things. Perfect. So
Oh,
I would like you to really look at this set of formulae so that you get familiar with them, right? And see and recall how did we connect them? You see, so basic connection was very simple. Let me just revise what we did.
subbing B as A.
Yeah. So basically, what are we doing? We are either adding these equations or subtracting these equations. That is one step we do, right? When you add, we get sine A plus B, we get this kind of formula, right? When you add, you get this kind of formula, right? Or that
Yeah.
kind of formula, right? It is add and substitute. So one set is add, second set is substitute. Substituting
Right.
A with minus B or B with minus A. Or
Yeah.
A. So substitution is the other. So you say, well, B is equals to A, for example, right? This is one substitution.
Then that gives you
Double angle.
double angle.
Right?
Yeah.
The other substitution which we learned is A plus B divided by 2. Sounds scary, but
Yeah.
you know, once you do that, you
It just
get a
follows the
different set of
same
equations.
format. Right. Right.
So these are the substitution which we did, but we actually played with only this set of formula. Is that clear to you?
Right. Right.
So if you remember
Oh.
this set of formula, you actually can do anything.
Yeah. Yeah.
It is good to remember others. I mean, it's difficult, but sometimes it's a multiple choice test paper where time is constrained. Those
Yeah.
may be helpful. But with practice, you will get them all in your mind. That's what I'm trying to say. You don't really
Right.
have to remember them. They will just come to you. They'll come to you.
Yeah.
Okay?
And they're not that complicated.
They're
Like
not.
even if you just wanted to remember them, because it kind of flows. After a while, it makes sense. Yeah.
And one of the major formula which you have learned looks very simple is the different values for cos of 2x, which is difference of square of cosine and sine, or 2 cos square x minus 1, or 1 minus 2 sine square x. Because that helps you to solve trigonometric equations and identities very efficiently.
Right.
You get the idea.
And that came from subbing in, or like knowing our trigonometric identity of sine
Pythagorean
squared x plus cos squared x equals 1. Yeah.
Simple as that.
Oh.
So we will end our lesson here, but I'd like you to kind of recap, summarize our learnings today. Yeah.
All right. Okay. So yeah, we kind of started the lesson with this page. I literally from scratch, haven't even seen this ever before. So yeah, this was quite like brand new to me. But even though it was brand new, it was really straightforward. Like I've never found a lesson this easy before. You said it was going to be easy, and you're right. So yeah, you just start off with the 4 main ones, the compound angle formulas, and we just were deriving every single equation that you see on this page, and it just flows so well that it makes sense. So like Sir said, with the compound angles, either you can add or subtract those values, and when you do that, you get either the product to sum formulas or the sum to product formulas. So that makes sense, and you can just easily see from the screen, A could be replaced with alpha and B could be replaced with beta, so it doesn't matter what the values are, is what I'm trying to say. And then to find the double angle formulas, you can just substitute the B and equal it to A, and then you get all those formulas in the double angle box. And then the important thing that you said about cos 2x is just knowing that using our trigonometric identities to sub those sine squared x and making it 1 minus cos squared x, and like that, subbing it in, you can solve trigonometric equations. So yeah,
Correct.
That's good.
So that's how it is. Simple as that. It's most interesting topic. Actually, I love this topic. Now, we'll also look into some practical applications based on these compound angle formulas.
Oh, like the plain one you were talking about.
Yeah, like that, right? Yeah. Or a searchlight scanning the whole thing, right? So these are all periodic things, and they scan through an angle, right? So
yeah, I think I saw in my book there was a chapter that said modeling with Trig or something, and
yes,
I think it included these formulas. Yeah. Okay.
Because good understanding is required. Once you have that connection, then those questions can be easily solved. Otherwise, they are very difficult to solve. So we'll look into those, but I'd like you to practice some questions from your book and some videos which I have. That should really help you. Okay.
Yes, we'll look into that playlist, sir.
Yeah.
So yeah, thank you so much for today's lesson. Yeah, just get on with the work, and then hopefully I'll see you soon.
Okay, then.
Have a good rest of your day.
Nice weekend.
And you, sir. Bye.